All right, today we're going to do basically a super single, effectively a single take on assembling Squeezy. So we're starting from the pre-soldered package. If you ordered a pre-soldered Squeezy from us and you ordered the radio and charger at the same time, the radio will already be bound to the Malenki. If you ordered the pre-soldered kit and you already had a radio, then you'll need to bind that to the Malenki. We'll go over that also. So everything here is what comes with your pre-soldered Squeezy. So we include basic hand tools to assemble everything. These are things that are really nice to have. So having a small electric screwdriver that can go really slow, it has to be able to go really slow, because if you run the screws into the plastic fast, even if you don't bottom them out, they'll still actually kind of melt the holes. So it's got to be able to go slow. Set of needle nose pliers, flush cutters, good drivers, and a file are generally just really nice things to have. We will have all of these available as recommended tools on our site. So anyway, let's get started. So what we suggest doing when you get a setup is lay everything out, make sure you understand how everything goes: arms, claws, slider, shoulder, link, wheels with collets, just so that you can understand what everything is. You'll have 4 slightly longer screws. Those go in all the pivots. One slightly shorter M3 screw that actually goes through the slider. The very short one adjusts the angle of the shoulder, and the skinny one goes through the link and the self-righting mechanism. And that's actually the pivot for the link to self-righter. So the easiest first step is servo prep. It's just much easier with it not installed into the bot. So KSTs are standard these days. They're really, really good. We buy a whole bunch of them. So it comes with one of the servo horn screws installed, generally has a spare in the package also. When we designed the self-righter, when we designed all of this, it was kind of made to work with any micro servo. Micro servos being roughly the size. The metal ones are typically about 20 grams. They tend to be very similar. So as such, a lot of them come with thinner and shorter horns than what comes with the KST. So if you're using the KST, you will want to knock this extra rib off and actually shorten it down to just above the top hole. The easy way to do that is you can knock a lot of it off with a pair of flush cutters. Always wear safety glasses when using flush cutters, because they can send debris everywhere. Anytime you're using something with brittle materials, you want to have safety glasses on. So trim that, and then if you've got a file handy, it's nice to smooth this down. So the small steps like filing, they are not necessary for assembly or function, but the little things go a long way. So by the same token, when we are setting up the slider, if this top's not perfectly smooth, running a file on it just a little bit so that the washers slide nicely across it. It's those little things that just make it make the bots function particularly well. When you see one that's particularly snappy and precise, it's those little things that do that. Like I said, you will need to trim this one slightly. So basically you're reducing this to the height of the same as the gap that's there between holes. You want only about that much over the top hole. And if you keep your finger over the edge, then it doesn't shoot pieces across the room. But again, you should still be wearing safety glasses. So that should be most of the trimming that we need to do. This will go in the self-righter. We want to make sure that we can hit all the right holes, and what that'll do is that'll make it so that it fits just perfectly right over, or just clears that back wall. Again, the KSTs come with one servo horn screw installed and a spare in the package. Batteries generally going to be in a little box. These are the new Turnabout batteries. So you'll notice that they say on them, so most 2S batteries are 7.4 volts, and then they would have a capacity listed. These, actually, in our pursuit of batteries that fit really well, particularly in overthrow, we ended up having these made. They are slightly lighter and smaller than most 2S 300 milliamp hour batteries, but they are technically HV. So if you have the right charger, you can take them up to 8.6 volts instead of 8.4, and at that point they'll have a capacity of 350 instead of just 300. So the battery is going to install there. Actually, it'll go in like that. So typically the charging lead and the power or discharge lead is arranged like this. The way it fits in Squeezy, you want to just tuck this back through because your charge port's going to mount here, and your power distribution is going to go to the front. So what we're going to do is note that the switch is off. We can plug the battery in there. We'll plug the servo in. Always make sure that you're yellow to yellow and then brown to black if you have black on your servo, or brown to brown this way. But it should always be pretty clear that there's signal, power, ground. Generally it doesn't hurt them to plug them in backwards, but they don't work. So you do want to go ahead and plug that in. So when I turn this switch on, I'll have the red and the blue flashing, which means this is ready to bind. With your FlySky, again, if you bought them at the same time, they're probably already bound, so you will not have the blue light. It'll just have a red light till you turn this on. Flashing blue, the Malenki's looking to bind. Hold the bind key, turn it on. So it says binding okay. You haven't heard the servo yet because I haven't moved the motors. So if you power up the Malenki and then turn on or bind a radio, till I move the motor stick, it's technically in configuration mode. So I could send it different commands for configuration, but mostly I'm just wanting to set the servo. So when I move that, the servo also moved. So I can see my motors move, my servos move. Now you'll notice that when the backlight goes off on the screen, I have to push a button to turn it back on. That also makes it so I can do the next step. So receiver it's showing that it's full, even though that battery is at 7.7 volts. That's because of the default. So as long as the backlight's on, you hold OK, and we're going to go into system setup. So if I went down, I would go to functions, but I want to do system first. So I hit OK. I'm going to go down to RX setup, OK. I'm going to go down to RX battery, and OK. Now these are set for a different type of battery. We need these to be 6.8, 7.4, and 8.5, but you can't raise this one above that one. So you have to use OK to go down to high, and then hold up to bring this up to 8.5. You could go to 8.6 if you are using the HVs, but 8.5 is fine. Go around to alarm. I bring this up to 7.4 because I really don't want to run batteries under 3.7 volts per cell. It's a 2S battery, so 7.4. But I want to see if I have, so I'm going to bring this up to 6.8, which is 3.4 volts per cell, which it should never get to. And then with these radios, you have to hold cancel to save. So now I've saved, I can go out and I can see now it shows the battery where it is. 7.7 volts is more than half used. So you can see that there. And again, I wanted to set my servo. So with the stick down, so weapon down, this should be slightly forward of perpendicular. So if I've, perpendicular slightly forward, because that's how it goes in the bot, and that should give me, when the weapon's all the way up, when I've pulled it back, it should be close to horizontal. And if you're using a different servo or whatever, then you can just kind of double check that it fits and doesn't hit the back of the chassis. So with that where I want it, I'm gonna make sure that that's on. That's really all I needed to do at this stage. So I can turn this off. I turn off my radio so it doesn't beep at me. I'm actually gonna set this aside for the moment, but I'm gonna go ahead and put the servo horn screw back in because that is where I want it. And a lot of servos like this, they don't have mechanical stops, so you could go around and around with it. So you want to go ahead and secure it now. That's the point of this first step. So this is a steel screw into a steel spline. So you could put some good torque on the screwdriver here because this is your main weapon. This is what's going to be squeezing. You want it to hold force. You want it to be really quite snug. It's actually the only Phillips screw in the whole assembly. I go ahead and split things back apart just to make life a little bit easier. I do find that the next easiest step is to go ahead and install the servo. It's easier to get the screws in when there's nothing else in the way. So we have these black M2x6 self-tapping screws, generally fit quite nicely on the provided driver. We tried to make everything 1.5 millimeter hex drive so that the same drivers would work. But to get the right size pivots, those have to be 2 millimeter drivers. And the tiny one that goes all the way through, I could only get in 1.3 millimeter, hence the 2 other keys. But other than that, everything's a 1.5 millimeter hex drive. Now, these, you're now screwing a steel screw into plastic. They have pretty good aggressive threads, so you can snug them up pretty well, but don't go nuts because you certainly can strip out those plastic holes. If you do, I'm gonna start including a couple of M2.5 millimeter screws that can be driven into stripped holes so you can still use the chassis if that happens. So servo mounted, once that's mounted, the servo wire is going to end up tucked in over here, but we'll really tuck that tidy once we install the switch. So the next thing I usually do is go ahead and install the battery. So again, discharge is going to go forward, charging is going to come back. Really like having the charge ports mounted. It makes life much easier. When you're charging, it makes it easier. You can just plug the charger right in. Now, they are necessarily tight, so they hold on well. But we did find that if you just barely knock the corners off of the charge port, not even all the way to the square, just a tiny little smidge of a taper on the edges of this. Again, you can keep your finger over the edge so that you don't launch it across the room, and you should be wearing safety glasses. That helps a lot in getting the charge connector to slide into the mount. It used to be I had to be really, really square to get that in. So again, necessarily tight to get in there. The wires, you can see the taper on the divider that keeps the arm off of these wires. Do kind of want these wires to primarily be at the back. And it can be, there we go. That's about it. So I'm wanting those towards the back of the bot, and then the discharge will be forward. So that'll be there. And then putting the whole harness in. So this will have come unwrapped. That's how we do all of our universal, this meaning this fits in all of the turnabouts. To make it fit into here, I've routed it as flat as I can across the bottom, and then these actually cross at the top. When I kind of leave the power one out of the way, what will be going over to the left side of the bot routes between the power and ground and the signal on the servo. And what I'll do is, so you can see it, the Malenki will slide up under the pivot for the shoulder. With the motors, I always like to have them where you can read what RPM they are. So with these, you'll have the black notch and the laser engraved RPM on the top. You may have noticed that we have retention features that hold onto the gearbox. So when you're installing these, you don't want to damage those retention features. You also don't want to spread the chassis too much. So I'm going to spread the chassis a little bit. You can see I'm flexing it just a smidge to take some of the pressure off the pieces that'll grab the top of the gearbox. If I do this right, I'll get almost no marks underneath and almost no marks where the gearbox passes the lip. So that's in there quite snug. The power will be ending up here. You can see where the switch will go into the switch mount. And what I actually found was most tidy was that these motor wires will actually be captured under this motor connector. So I'm gonna make sure that I install this one the same way, where I'm lining up the gearbox. I'm gonna flex the chassis just a smidge as I snap that in place. Now, I do want to make sure that I haven't pinched this wire under the motor, which I did manage to catch it just a bit. This is another place where those those might be nice. So I generally try to avoid having to take a motor back out, but it's the same thing. I'm going to flex it just a bit, pop it loose. So I'm going to try a little bit harder to make sure that's out of the way. And again, flex it, push it past. The main thing is, what you don't want to do is put this flat on a table and jam the motor in. Because if you do that, the motor is holding the chassis very flat and you're going to force the gearbox by those edges. So as long as you're holding it, you don't have to flex that so much, but you don't want to put it down on the table and jam it in, because that will damage those retention features and then your motors won't be quite as snug. But you can see that I've ended up quite tidy. These wires are tucked down under that connector. Everything fits nicely. It'll be very tidy as we start to finish it up. So the next step here is going to be to put the switch into the switch mount. So again, like the connector mount, it's necessarily tight so that it holds it securely, but it takes a little bit of effort to get the switch in place without damaging any of the retention features. So the long post inboard middle is designed to be able to flex a little bit. And should let me slide this in. Get that to snap in place. I'm trying to avoid using the needle nose. I could hook it with one of those, but it is just a little bit easier to be gentle and precise with some decent needle nose pliers, which are good to have around all the time anyway. I'm gonna get that to fit Gonna make sure it stays visible. There we go. So when this is where it should be, that post will snap in and hold the top of it. So you can see that post is now back to being vertical, and the switch is easy to get. It's basically flush with the chassis, so the side armor will be slightly above it. So with the switch in place, then we can start, I hate to call it stuffing our wires, but that's basically what it is. So again, we have our servo connector coming from the Malenki. It's yellow up, brown down. This similarly needs to be yellow up, brown down. I really like to tuck the connector itself right next to the servo. So there should be exactly enough room to get the connector down there next to the servo. And then there is still enough room to, for lack of a better term, stuff the wires in and around the switch. So if you are going to competitions and you want to use more TPU accessories and you're tight on weight, obviously this is a fair amount of wire right here that you can always cut and then direct solder your servo to the Malenki, saving weight, room, things like that. But then obviously it makes swapping servos harder and more time consuming during competition. So that's why we use all the connectors, so that if you do end up needing to swap it quickly in combat, you can. So we'll turn that back off, and you can see that we can then lay this flat along the top of the servo, and if we do this right, we'll have one layer, there you go, one layer of wires just like that. So the battery's nice and tidy in here and snug. And this is how we want all of that to end up. So the top armor, when you put the top armor in place, it'll hold it quite well like that. I want to make sure that there's still plenty of room for that to go. It never goes that far forward, but that's the intent, is to keep all of this snug. Like I said, the top armor will help hold that down. So this is our assembled chassis. It's always good to test along the way. So I can turn that on. You can see the red light because the radio's not on. You need to have that down. So if I turn it on with any of these up, down instead of up, then it'll beep, and I got to put this down. So now it's connected. That one starts the mostly solid blue, the light flicker, and I can see my motors move and my servo moves. So looks pretty good. The next thing is zip ties, which actually are better to do even before you install these, but it's still easy enough to do here. We always laugh that I almost always forget these until the bot is almost complete. But didn't forget too long this time. So these function as a sprung tail or a spring tail to help keep the wedge, once the wedge is on, wedge on the ground without unweighting the tires too much. So that's why you have a sprung tail, to keep the nose down, keep your ground game good. So we use things like this a lot. Nylon zip ties are good, handy, easy to replace, very available. So but you always want to be aware, where is the tail going to be? Because we're actually going to use the tail of the zip tie to do this. So I want the tail to come out the bottom. That's going to be the springy part, which means I need to put this in like that. And there's enough of a ramp that these do slide right back in. Again, in competition with spinners and things, they might get broken, but that's why we use a zip tie, because easy to replace. And honestly, good nylon zip ties are quite robust. So what we'll want to do is get this snugged up. There's a good flat that this should sit against right there. Now you do want to, you want them tight. You don't want them down too far because you don't want the head, so tail, head, you don't want the head riding on the ground. What you're gonna want is to have a good curl on that, have that good and snug, and then we're actually gonna trim that so that this is the part that is the sprung tail on the ground. So we do the same thing on this side. Think about where we'll want our tail. So it goes in there first, turn it, you'll go back down around the mount, back through. So we actually use the same thing on the claws, where we'll use the zip tie as ground scraping wedges or forks for the claws. So what we're going for is the head's good and tight. Don't break the zip tie, don't break the chassis, but then we'll want those curled down so that they'll be, when the ground is here, there'll be springs. I generally leave them 3/4 of an inch, and I cut them on this angle, I don't know, because it looks cool, and it makes even more springiness at the tip. You can play with it, see what length you like. The main thing is just that they're sprung down. There we go. So then we'll go ahead and do the arm assembly. So the claws, they are technically symmetrical. I like to put the smoother side. You'll notice that there's a slightly perceptible pattern on the side that wasn't sitting on the bed when it was printed. We do print them so that there's a right and a left. It's not that big a deal if you switch them. The slider slides on the top, but I like them smooth side down. So I'm smooth side down, and then claw will have the zip tie mount down, which means that this is the right arm and claw. You'll notice that there's a barb, there's a retaining feature in there. So when you push these all the way in, they hold on really, really quite well. Now, that said, if you're going into competition, a thin amount of super glue or CA, cyanoacrylate, here, and maybe even a little bit in there with a spritz of activator, they're definitely not coming off. So there's my right arm and claw, my left arm and claw. And that does retain quite well. So these will go on the shoulder. That's the shoulder. And that's how those will pivot. You'll see that we have so that one is slightly shorter. It's just 2 millimeters shorter. That actually goes through the slider. But with each of these, we use our 1 millimeter aluminum washers. They don't really have an upside because they're not stamped. So it's never a bad idea to make sure that those slide well. But the first thing we're going to do is arms to claws. So left arm, again, zip tie mount down, smooth side down, left side. And those drop right through there. Shoulder. Now, and put this together. These are 2 millimeter hex drive. So you can use the 2 millimeter driver to do that. I like to do that, have the arm against the shoulder initially so that I know that it's going in square. Once it's started, then I can just hold on to the shoulder and turn the screw in. And what I almost always end up doing is getting it to the point where it's just snug enough that there's some resistance, and then back it off like 1/8 of a turn so that it is plenty floppy, slides smooth, but there's not slop. So same thing for the right claw, longer bolt, 1mm aluminum washer, through the claw, onto the shoulder. Go ahead and start that. If it's easy to hold while you finish tightening, it's fine. If you end up letting go of the claw once it's started and it's nice and perpendicular, you can go ahead and do that. And we'll tighten it up to the point where it just snugs. We'll back it off just enough that it's floppy, but minimal slop. So the next thing is the slider. The slider goes there, and then that actuates. We use the same stuff. The longer bolt, aluminum washer, through the slider. Now, because the slider is not long enough to hold that perpendicular, you just want to pay attention to it. So, and this is going to be pulled back, so making sure I'm still aware. Well, the shoulder is going to have to go down, but you want to make sure that the link mount is above the flat, above the arms. So that's the orientation you want. You want it pointing to the back, and the bumps will be up. You can often start these with your fingers. You do want to make sure that it stays perpendicular, which means try and view it in both planes. So I'm looking at it here, making sure that it's not bent this way, and then also look at it that way and make sure it's not bent over neither of those two directions. And then when you're sure it's square, you can go ahead and turn it in. Now, there's steel keys, steel hardware, so that joint shouldn't strip. But obviously, if you run this in too far, you can certainly strip the plastic with the key in this direction. Probably will switch to electric for the next one, just so you don't have to sit through and watch me tighten things. So making sure that that slides nice, pivots nice, there's no resistance. Some of these are great to have, just small electric, or if you have the right bit for that one. But you grab the last of the longer bolts, the M3s, through the washer, through the slider, and let's see if this has enough charge to run this in. It does. Almost. So I'm gonna get it all the way snug down. You don't want any resistance in any of these joints. So if you go till they touch, you should back them off just a smidge. And then what you should end up with is a mechanism that moves really, really freely. So it should just, even by gravity, it should be not sloppy. You'll notice that there's very little angle available on them, but it is plenty loose, that it takes no force, slides nice. So that is your arm shoulder slider assembly. It's gonna go right there. The aluminum rod goes in underneath. Before we install that, probably is easier to go ahead and mount the self-righting mechanism. So because the link will be on this side, the topmost screws will be on the side where the link is not, so that when that's all the way back, it doesn't interfere with it. So we'll put this on this way, and I'm making sure that I can see down, I can see the third hole down. So my bottom screw will actually come through this side, and I can see in here that I have 1, 2, 3 holes. So as long as I'm getting to that third hole with the screw on this side, then I know that this won't hit the back of the chassis. So I may actually go ahead and start with that screw. The bottom. And you do need to support this side to make sure that that self-tapper engages some of the far side of the self-righting mechanism itself. And you can run these in until you get a little bit of plastic deformation. That's okay. Don't strip them out. They're just going into plastic. So then the second screw will go in the top hole, and that is on the side that will not have the link. Self-tappers are sharp, so they may very well try to bite into the horn, not through the hole. So what I'm doing is getting a little bit of angle on it to get the self-tapper up into the hole of the arm. So I want to make sure it goes through the hole. So the arms are a much tougher material. I think in some servos they're actually UHMW. So that's why it's important that these screws go through the PLA and engage with the servo horn. We do actually have the weight in Squeezy now. You can run a second one through there. It's not really necessary. None of the ones that we've battled for the last few years had more than those two in that. So it works, you know, it fits, it doesn't hit the back of the chassis. We can go ahead and install the shoulder down. So the aluminum rod will go through. Ideally, it slips through and pivots nicely on the shoulder. We will want it to be snugged up into at least one of the mounts. So to do that, you can use a little bit of glue, but what we often do is if you just give it a little bit of a squish, deform it a little bit on one side, then, you know, obviously put the other side in first. I'll go through there, then you can carefully just press that till it's flush. And that aluminum rod won't come out if you don't want it to. Or you can force it out this way, but it is quite well in there, and the shoulder pivots nicely. At this stage, before you've hooked everything up, it's good to go ahead and put the zip ties on the motors. There are usually 4 zip ties in this kit. Grabbing mine from over here. So again, you always want to be aware of where the tails are. So I want the tails up on the back side of the motors, which means I'm gonna put these down in the front, and they'll come up in the back. And when I do this, you really do want these quite snug. Now, the motors do have the retaining features, but in the heat of battle, you want your drive line as precise as it can be. So what I'm actually gonna do is I'm gonna grab this tail, I'm gonna roll it a little bit, and what that does is it pushes down on the head while it pulls up on the tail. And often I can get like one more notch. You want to make sure that that is, it's tight enough that it's gotten all the way flush. If you end up breaking that off, that's just fine. As long as it has enough tension that it's really tight on the bottom. So again, thinking about my tail being on the back of the motor, go down that side, back up this side, and having it so assembled, it's going on the wrong side of the servo wire, so I just give a little bit of pre-bend to the zip tie, go back up, then it comes up right where I want it. The holes are snug. We do everything we can to keep things tight and tidy so they don't move around. So you'll see I'm pulling it forward, and then as I pull it back, it tightens up. You can see it tightening up the bottom. Again, I'm gonna give it a bit of a roll. Actually, just go ahead and roll it till it breaks. And then our motors are in, motion is there. So then we do the link. The link, small hole goes in the back with the other small hole, big hole goes in the front with the other big hole. Do this. This can actually be done on either side. Start it before you're holding the link in place. Obviously you do want to make sure that this moves freely in there. Honestly, with the new printers, it does great. For expediency, I'm gonna use this again. So I snugged it till it was held and then broke it loose. So then that one's gonna go there. This is the one place where we use the 1.3 millimeter driver. It comes with that 1.3 hex key. So this is a very fine thread. It's gonna go in there. The link should let it go through without biting, so you don't have to turn it all the way through those. But you can use the key to tighten this all the way in. Again, expediency, I love these wear drivers with the Hex Plus tips. They are amazing. We have those on the site in the recommended tools area. That goes through. In competition, it's not a bad idea to put a drop of super glue and accelerator on there. Again, not necessary, but so you can see we've got our motion. So all of the kits always come with a paper clip. In Overthrow and Slammer, the paper clip is actually used as part of the pivot. In Squeezy, it's used to make a hook to pull the rubber bands through. I'm not gonna make you sit through while I bend that hook, but you want a nice tidy little hook. Another place where having some needle nose is great to have. So most of the kits come with at least 6 of these rubber bands. Generally use about 4 of them at a time, so comes with 2 spares. If you want more gripping force and less lifting, or more gripping before lifting, you can put more rubber bands on it. But we found that 4 of these is pretty ideal. Take the hook, go through from the bottom with it pointing out, hook your rubber bands, try to avoid twisting them as much as I can, and you'll just hook that on that post, and then make sure you're grabbing all of them, loosen your hook, flip it around, again, take your hook, go down this time, hook your rubber bands, pull it up, and then this last one, I use the hook to make sure that I'm actually getting half on each side. And you can see that even as many times as I've done this, gotta make sure that I've, got 4 strands on the right, 4 strands on the left before I let go, or else it pops through, and then you gotta refish them. Not that that's that big a deal, but there you go. So you can see from here that it allows a downward angle. Normally we'll want that much closer to flush. That's where the short screw goes. So short screw, is in there. Once again, for expediency, I'm gonna use the electric to save you all some time. Well, I thought I was. And we'll do the final setting of this height once we can move it, but we're looking for it to be closer to horizontal. Again, we'll go over that setup when it's fully assembled. So there we go. Everything looks good. If you want to double check it again, you can, and see it works. And then we'll go ahead and install the wheels and tires. So with the collet wheels, so you drop the collet into the tool. We'll go ahead and just get these started. Sometimes the collets have stayed with the wheels in shipping, sometimes they haven't. But you just drop that in there and just put them on, just so that they're there. You do want to then go ahead and install the tires before we start to put it on the bot. You'll see why in a second. So the collet wheels have a D flat, as do the motors. So you can see that there's a D there, a D there. So flat up, and then you'll push this together. Now, just given the variety of options out there, we did not put a stop on these this time. So that's why we have these spacers, to make sure that you don't have the wheel too tight to the chassis. Just pop that on, and then you want to make sure with the tire on and the spacer in place that it is not rubbing too hard. So once it's there, you can go ahead, you'll hold the tire, use the tool to tighten that up. Once it's a little bit snug, I get that out of the way, just it's not bothering my fingers. And then go ahead and tighten the collet. You should be able to tighten these pretty much as hard as you can and not break it. You don't have to go nuts, but you can see these hold really, really well. They're easily uninstallable and reinstallable. And we're really pleased with that. That was maybe 30 iterations to get this. Look at that. So I did manage to pull it off. So the motors come in oil so that they don't corrode. If you go ahead and clean those shafts a little bit with anything, if you've got ISO sitting around, or even just a good clean paper towel, and loosen that collet back up, flat up, my spacer again. Spacer out. So we are about to release some special motors that have a coating on the output shaft that'll make it so even when a small child tightens this collet, it's kind of a motor wheel combo package, but even a small child tightening the collet will make it effectively unremovable. And if you crank it down with the coating on there, it'll hold over 20 pounds without being able to pull off. So other side, go ahead and wipe that motor shaft off. And so I've gone D flat up again, D flat up. Start it, put my spacer in, slide that on, make sure I can still turn the wheel nicely. Grab the tool, run the collet down some, take the spacer out of the way, and snug that up. So those wheels are on there. Wiping the shaft is important. Okay, so all that's left at this point is the top armor and the front armor, and then zip ties for the claws. So for ease of handling, I'm going to go ahead and put this on next. Again, you can use that. This is the first place I've really like using this one. So the beauty of this particular driver is you can squeeze it gently and it'll turn really, really slowly, which will keep it from melting the holes that it's going into. So once it bites, I want to slow it down And really, not even 1 revolution a second, just to make sure that I don't melt that hole. Again, as we're going into plastic, you don't want to over tighten. All right, last step is putting the plow on. You'll notice that there's a ridge here on the plow that is intended to clip into this. So you do want to get this on there before you start screwing it on. You don't want to start screwing it and then try and jam it on. It's intended to clip under there a little bit to keep that plow flat on the ground. And then with that all held together, we'll go ahead and run this in, again, not too fast. So you don't melt the hole. And the last screw. So making sure I'm still all the way flush. Put this in. So that's basically it. We'll go ahead and do the, so you can see the plow is flush, and when I push down on the back, it flexes the sprung tails, so that's really how I want it. To set the height, so we'll go ahead and turn this back on. We'll turn on the radio. So you can see the claws themselves are scraping the ground, which will mean that they're unweighting the tire slightly. And we don't want that. So what we're gonna do is we're gonna raise the claws by turning this screw down, and a quarter turn is actually kind of significant. So now, take that out. So now my claws don't touch the ground all the way around. They're close. In fact, they're far enough. I'm gonna take like not even an eighth back off of this, just a smidge. And now I'm watching the distance. You know, I want it to be about that much off the ground. So if I go any lower, it'll, you know, it's not that high off the ground. So that's about the distance that I'm trying to get it. So that screw's set correctly now. I can, at this stage, if I want to go ahead and set the, we'll do the zip ties next. So turn that off, we'll do our last pair of zip ties.